Hello and welcome to this latest installment in the Black Hat webinar series, The World Through 10 IPs, What IP Intelligence Reveals to Investigators, sponsored by IPinfo and broadcast by Black Hat and Informa Tech Target. I'm Terry Sweeney, contributing editor to Black Hat, and I'll be your moderator for today's discussion. A little bit of context for today's session. IP addresses are a combination of caller ID info, geo coordinates, and so much other metadata about networks, connectivity, and location, among many, many other parameters. Our speaker today will walk us through these IP data bits and how SOC professionals can leverage them more intelligently, ideally to do their jobs better and to reduce risk, and all that dodgy stuff that traverses IP networks. All right. In that vein, I'm also excited to welcome our speaker today, Ben Dowling, founder and co-CEO of IPinfo. Ben, welcome, and thanks for making time to talk with us today.
Hey, Terry. Yeah, thank you very much.
Before we get started, just a few quick logistics to remind our audience of a couple of things. This webinar is designed to be interactive between you and the speaker. You'll see that Q&A box that allows you to send us questions for the Q&A that takes place at the end of the presentation. On your screen, you can also see the buttons to click on to learn more about today's speaker, download a copy of the slides, and also share this webinar on social media. You can also use that Q&A area to let us know if you're having any technical issues, and our team will do their best to help you out there. Ben, that's it from my side. The floor is entirely yours. Take us away.
Perfect. Thank you, Terry. So here we go. The presentation today is the world through 10 IPs. So let's get started. Here's what the next 40 minutes is going to look like. I'll give you a bit of an overview at the start around what's going to be in the presentation, a bit of an overview about us, who are we at IPinfo, what do we do. I'm going to give you a tour of these 10 IPs and become apparent exactly what that is. But talk about these different contexts and different IPs that you may see in your investigations and your web logs or whatever, and what context IPinfo can kind of bring to those environments. Then we're going to flip and talk more about those data sets. So for each new IP address, we're going to introduce a new piece of context that we're able to offer at IPinfo. In the second half of the presentation, we'll go deeper into those data sets, what they mean, what the context is, and tie it back. And then a quick recap of kind of everything we've covered. And at the end, we've got some time for Q&A. So I think, yeah, as Terry said, kind of during the presentation, feel free to add the questions into chat. And at the end, we'll have a chance to go over some of those. And we don't get to today, we can follow up over email. Always great to get more questions. Cool. So let's start off with what we're going to be talking about today. Today we're covering 10 IP addresses that are all geolocated in Seattle. And so, I just picked Seattle because I'm here in Seattle. But the same principle applies to any city, either that you're in or that you're investigating, or that you see an IP address from. IPinfo, one of our sort of core data sets is geolocation. Given an IP address, where is this IP address in the world? Seattle, what city is it in? But what country it's in, what region it's in. And that's a really critical data point, really critical enrichment. If you see an IP address, it's almost always valuable to know where it is. But it's often not enough, right? There are examples where that may give you everything you need to know. There may be use cases where that's everything you need to know. Whereas today, the presentation is going to really focus on 10 IP addresses that all give you that same answer. There are IP addresses in Seattle, but as we get into richer context, we'll see why those other data points might be valuable. So who are we at IPinfo? Why are we giving this presentation? What is it we do? I already hinted about that, right? We're an IP data company, and so we create rich contextual data sets about the internet, about IP addresses. We are sort of, I guess one of the data sets we might be most famous for is geolocation. We have really great, really accurate geolocation, and I'll talk more about kind of how we do that, some of our technology, and some of the things some of the ways that we approach that. But the core, I guess, point of this presentation is that geolocation is often not enough. It's a great starting point, but you often want to go deeper. And so we've got 16 data sets today, some stats about sort of the types of data processing we do, API response time. One of the key, I guess, inputs into all our data sets and the work we do is our ProbeNet. We've got servers in over 1,300 locations, over 160 cities. half of all ASNs are within 1.3 milliseconds of our probe net now. So we've got incredible reach, actively investing and growing in this. And this is sort of a key differentiator for us in kind of how we put our data together, and a key difference in our approach as well, which is to kind of deeply understand the internet, understand how it connects, how it's put together, and then create these data sets and these rich context as a result and as an output of that. And I think the evidence first piece is really critical here, right? A lot of our data sets are based on things we observe, things we can measure, and we want to create factual, rich contextual data about IP addresses. And then a little bit about our research team, right? So that being our focus is sort of this deep understanding of the internet. We have a research team that's really focused on building this understanding, on creating internet standards. And so, yeah, this speaks a bit to our approach. Some of our customers. So some of you may already have used our data or played with our data. Our data is available in a download API. A lot of our data is available freely on our website. And so, any of these IP addresses you can kind of follow on our website, IPinfo/an IP address. We can just go to our homepage and click my IP and see a lot of the rich context we've got. So that's one way to experience our data. But we've lots and lots of customers, lots of industry leaders that use our data, either internally, some of these companies here, their cybersecurity teams might leverage our data internally for protecting the corporate network, but many of these companies will leverage the data in their products and services. And so if you're a customer of one of these companies that are our customers, you may already have experienced our data, already have used it, already kind of benefited from it. So I think we're going to go to a quick poll now before we kind of get into those 10 IPs.
Great. Let's take a look at this, audience members. We are asking you if you're currently using IP context data, whether it's geolocation, ASN, VPN proxy detection, as part of your stack. Answers are there for you to pick one. This is a good temperature taking exercise, Ben. This is a good place for us to start. I don't know if you're a gambling man, but which of the four answers do you imagine will garner the most responses?
My guess is yes in production. That's sort of, that's definitely what I experience most talking to our customers, obviously, right, that are sort of already using data. And generally my conversations there are, great, how can we give you even more context, right? And so you're already sort of using maybe one or two of these kind of pieces of context, and then explain to our customers how they can get sort of even more and even richer. But obviously, I realize that my sort of universe of talking to our customers, that could be people that are sort of already further along than the sort of the broader set of people. So I'm really interested to see if our audience today are sort of already in that camp, or if there's in earlier stages of kind of piecing together how this might work for them.
All right. Well, I want to just give our audience just maybe another few seconds to log their response there. Let's see. Bradley, do we need to push these results to our audience?
They can see your results.
Excellent. So it's pretty clear. We have we broke the tie. Yeah. So maybe not completely surprising. Yes, the winning response is in production. A little more than a third of the audience, but yeses comprise almost 70%. So Ben, are you hugely surprised here, or does this align with your expectations?
Yeah, I think it's somewhat aligns, right? So it's not a shock. Great to see there's a mix though, right? And so I think for those, 36% that yes are using in production, hopefully today I can sort of convey maybe some new data sets they hadn't considered, or some interesting pieces of context. And then for the others, hopefully, the useful information that might nudge them to be using it in production.
Excellent. Well, audience members, thanks for participating. We'll be back in just a few minutes with a second poll. Ben, back to you.
Great, thanks, Terry. Cool, so let's start. So the world through 10 IP addresses. And like I say, they're all in Seattle, but that's it's an arbitrary choice that I made because I'm in Seattle and I'm familiar with a bunch of these. The same principle applies to sort of any city in the world, right? And the point is that geolocation, while it's a really critical and important piece of context, much richer information is available. And so let's start with one IP address. This is actually my home IP. So this is my home IP address in Seattle. And you can see some of the context we've got, right? Geolocation, obviously, Seattle, Washington, US, that's the context that's going to be common across all the 10 IPs that we go through. Here you can see network information. And so I'm a Comcast customer. You're Comcast, one of the biggest ISPs here in America, AS7922. We have ASN classification. So we're saying, hey, this is an ISP, host name. And so, generally, when we think about geolocation or a whole bunch of use cases of geolocation, this is sort of the common sort of canonical example, right? We've got an IP address that geolocates to Seattle, and that means there's a user in Seattle, right? And that's often the case, and that's certainly the case for this type of one, right? It's a residential ISP in Seattle. It's my home IP. And in the sort of the when IP geolocation first got started, some existing vendors that are still around today kind of grew up in this world where this was the case for the majority of IPs on the internet, right? A world with dial-up. There were not mobile devices in the same way today. There were not VPNs and proliferation of data centers. And so obviously, the internet has got a lot more complex in say the past 20 years. That trend will likely continue. And so while geolocation was super important 20 years ago, remains important today, this 20 years ago, this type of IP address would have been the majority of IP addresses that people would likely encounter, right? Consumer ISPs, there's an IP address, you map it to a city, and you have a user in that city. And that is true for residential ISPs. As we're going to see throughout this presentation, there are many, many more types, right? And so there are all sorts of use cases where geolocation might be all you need. If you want to do some personalization, you've got a visitor to a website, you can assume it's a user and these types of things. But yeah, as we're going to see, lots of cases where rich context is important. But this is a sort of a canonical example where if all you've got is a location, you might be able to make an assumption or might implicitly make the assumption that that means there's a user in that same location, and it could be residential. So this is the first one on our journey. And as you're going to see, as we go through the other examples, we're going to layer on additional context on top of this. So the second example is a mobile IP. And so again, locates to Seattle, but this time instead of Comcast, we've got a T-Mobile IP. And so T-Mobile, they now do fixed wireless. You can get a T-Mobile router to your house, but it still connects to their wireless network. Same sort of pool of IPs that they share with people that are out and about on their cell phones. And so here you can see the additional context we've got is mobile true, is a flag that we offer. Our carrier data set will also give you attribution to which mobile carrier that is. So we see this is T-Mobile. We've got the mobile network code and a mobile country code. But this is still a Seattle IP, right? But it's not vastly different from the residential one, right? In this case, we've still got, this is me out and about on my mobile phone. I'm a T-Mobile customer. You might see me in your logs with this IP address. And you've still most likely got a user in Seattle. There are a few things that are implicit in this, right? So the fact I'm on my mobile, I'm likely on a mobile device. I mean, I could be tethering or something, right? But I'm likely on my mobile device. I could be at home on my mobile device, although when I'm at home, I'm usually on my Wi-Fi and not on my mobile connection. I could be out and about. So I could be out at the weekend. I could be, an hour or two away from Seattle, right? Still within sort of the Seattle metro area, but if I'm out on a hike, say, I may still have the same pool of IP addresses. I may be 2 hours out of Seattle 1 minute. I may be an hour north of Seattle, later in the day. And so, implicit within this is something around sort of the location constraints, around the location stability, also around the number of users. And so, the mobile operators use carrier grade NAT. And this is not my IP address, right? My house has a IP address from Comcast. It rotates every couple of months. But during that 2-month period, that is my house's IP address. Comcast might switch it out, but over that sort of month-long time period. On mobile with carrier grade NAT, there will be thousands, tens of thousands, hundreds of thousands of T-Mobile customers within the Seattle metro, and we'll have a pool of IP addresses that we connect through. And so, if I'm on my mobile phone, might go to the IPinfo website, and see this IP address, I might refresh and get a different IP address. There is a pool of IP addresses that I connect to the internet through. And so, this IP address does not map now down to an individual user or household. This maps down to a set of T-Mobile customers. And different mobile operators may do their networking differently, and they do. We see that. They might do it based on different customer counts in that pool. They might do it based on geography, based on all sorts of different things. And so one thing we've seen is that T-Mobile actually do keep that pool fairly geo-constrained. And so if I went much further away from Seattle, I would be assigned to a different pool. And so the geolocation here, while it's fuzzier than sort of individual residential, it's still relatively accurate. AT&T, we use a much larger pool. And so, the customers you see on those IP addresses might be from an even bigger region. And then you see different pool counts. So how many IPs does that network have? How many customers they allocate per pool? All these are different attributes, a whole bunch of ones that we study internally, measure, and then put into our attributes. So one is the carrier detection. We have device count is a data set that we've got in public preview, where we kind of estimate how many devices we think on this pool within a day. That kind of gives you some data there, and the radius as well. What's kind of the spread of usage. When we get into the data side, I'll talk more about those different data sets. But so we've gone from residential that ties to a house and to an individual or a household. Now we've gone to mobile, where this location still correlates to a user or a set of users in that location. The location is just a bit broader, the number of users broader, but we can already see that there's richer context that is useful here. So next, let's go to a coffee shop. And so this one's really interesting, and this one leverages our new places data set. So this is actually one of my local Starbucks. I'm here in Seattle, so there's an abundance of Starbucks. This is one that is near to me. And if we look at the metadata here, we can see it's obviously still a Seattle IP address. It is still Comcast, which is interesting. So, some coffee shops and some corporations might have their own networks. Some might use, enterprise ISPs, and some will just use the local ISP. And you can see that, in the case of my local Seattle Starbucks, it just uses a Comcast internet connection, just like I do at home. And so, if we just had geolocation ASN metadata, we would not be able to differentiate this IP address from either my own house or a random sort of residential IP in Seattle. With our places data set, we actually offer much richer metadata for public Wi-Fi hotspots. And so you can see here, we'll actually give you the name. This is Starbucks in this case. We'll give you a category, which in this case is a coffee shop, and we'll give you the SSID, Starbucks Wi-Fi. So that's the name of the public Wi-Fi network you're connected to. And we'll even give you building level coordinates. And so, the other examples will just tell you Seattle, city level accuracy. Here we can go right down to the building and tell you the specific Starbucks store that this IP address ties to. And so, again, there's a bunch of stuff still implicit in this. So one thing that's implicit is this no longer represents an individual user or household, right? This represents people that go to a Starbucks, connect to the Wi-Fi. And so if you see this IP address in your logs, you can know that it was someone at a Starbucks. And there are all sorts of implications for that. And we can talk more later in the presentation about the implications for what you might want to do with this data. But the key point here is that context we're able to provide you so that you can do different things with it. It's no longer hidden that you see a Comcast IP address, and the most Comcast IP addresses from Seattle will be residential, but within that there are a whole bunch of different businesses, a whole bunch of public Wi-Fi hotspots, and our places data set will give you that really rich context about them. And on when I get into the data more, I can go more into it. But really rich data point that will identify that this IP address, while it looks on the surface, and even with geolocation and ASN data, this looks like a Comcast residential ISP. This one is in fact the public Wi-Fi hotspot IP address for a Starbucks. Next up, we've got a residential proxy. And so there's been lots in the news lately with the FBI taking down NetNut, with the Kimwolf infections. This seems to be a current hot topic. The residential proxies, essentially these are normal residential IP addresses. And so you can see that here. This is an IP address that geolocates to Seattle. It's a Comcast residential ISP. So that, the same as we've seen in Starbucks and my home connection. The richer context we've got here is that we've actually observed this on a residential proxy network. And so that could mean, what that does mean is that, third parties can exit their traffic through this IP address. All sorts of reasons for that, all sorts of different motivations, and all sorts of different remediations you may want. And so that's sort of out of the scope here. But the key metadata that we've got here is that this has been observed as part of a residential proxy network. And we'll give you the metadata about that. So here we've seen it as 711 proxy. We've seen it on 100% of the days that we actively monitor all these residential proxy networks 24/7. And some IPs can go in and out of residential proxy pools. And so you may want to tune your response based on that. But this is one that we've observed pretty consistently active as part of this proxy network. We've got a last seen date. And so we're able to give you that context that you can go and kind of write different rules or different responses to. And so this is a really interesting example, right? Comcast residential IP, with the geolocation there and the ASN, these could all look the same. We've got three very, very different contexts here, right? A residential IP that is not a res proxy, a public Wi-Fi hotspot, and here is an IP address that is part of a residential proxy network. So there's three residential examples there. Now switching to some hosting examples. And so this one, you see the additional context flag is hosting true. This is AWS and AWS range, Amazon Web Services, Seattle, they're based here. They've got a bunch of data centers here. And here's an IP address that we can see is an IP address that belongs to Amazon as part of AWS. Not metadata here, so you're not seen as a VPN exit node or whatever, and we'll get to examples like that. Again, you may want to act on this in different ways, right? Depending on your use case, your risks, how you want to mitigate it. But it's a really interesting data point. And this is obviously very different from my home IP address, right? Where we've got a user that is in Seattle. Here, there might not be a user at all. There could be some code that's running on the server. It could be that you see an egress IP from a machine you're monitoring to this IP address. That could be completely fine. Maybe you see someone accessing your website from this IP. That could be someone tunneling through it. It could be some script automation. And so you might want to do something differently with it. But you're with that sort of hosting flag, you're able to differentiate this from, hey, we've got someone sat at home doing something versus, hey, this is an AWS IP address. That may be fine in your context. That may be something you want to do something with or flag, but maybe something you want to block. And so that sort of hosting flag really allows you to kind of differentiate and do something different there. Now, getting deeper into the world of hosting providers, right? And so just like we saw with residentials, a whole bunch of Comcast IPs in different contexts, the same is true of hosting IPs, right? And so we're able to provide richer context around different sort of environments and different behaviors. And so here we've got an example of a VPN exit node. And so this again is a hosting IP address. It's not AWS this time, it's DataCamp that have a data center here in Seattle. But here we're not just able to provide you the operator of that IP address, we're able to detect the VPN, a commercial VPN provider that actually exits traffic through this. And so this is NordVPN in this case. And so if you've installed a VPN, you often have a location selector. You can drop down and say, hey, I want to exit my traffic through this location, right? And so NordVPN customers that may go and say, hey, I would like my traffic to go through Seattle. This is one of the IP addresses that their traffic would exit through, and be able to detect that and give you attribution on the actual provider. And so again, we have the VPN flag, but then we have the provider. Depending on your risk or events you see, you may want to just say, hey, we don't want any VPN traffic. We can block it, and we don't really care about the provider. But it may be that you've got legitimate customers using some VPNs and you see some abuse from some different ones. And so by giving you that provider, you're able to kind of get more granular and act on different providers in different ways. And so, we'll give you the name of the actual provider. I believe our data set includes around 250 major commercial VPN providers today. We're constantly adding new vendors, so that set of vendors that we give attribution to is constantly growing. And then our goal for those vendors is to be able to get as much coverage. Our goal is complete coverage of all their exit nodes. And so we do a lot of work on that, and then that's included in our privacy detection data set, which I'll talk more about. Here's a Tor IP address, and so also a hosting provider. This time it's a different vendor, Contabo. It's not a VPN exit node. What we do see though is that it's in the Tor network, and so again, what you might want to do here depends on sort of your what risks you handle what your exposure is and all sorts of different, your own circumstances. But implicit with this being Tor is a whole bunch of things, right? So with a VPN, VPN providers, often you have to pay for them. They may have records of their customers. You may experience different types of risk from different ones. Tor is a completely open network that anybody can connect through. All sorts of legitimate reasons to use Tor, but there can also be abuse from it. And so you're having that flag, you're able to treat this traffic differently than you might other private services. But this also means this is where the traffic is exiting from. It's not where the user is. They could bounce through a Tor network from anywhere. It also means you're not identifying an individual user. There could be thousands and thousands of users exiting through this IP for all sorts of reasons. So that flag allows you then to go and act on that in whatever ways you might want to. Here's an Apple private relay. So this is, again, a different type of anonymity service. This, again, a bunch of stuff implicit on this, right? So, Apple has a iCloud private relay. It's enabled for default, I think, for iCloud Plus subscribers, but you can enable it on your phone. And then as you're using Safari, your own network's IP won't show up. It will show up as Apple private relay. This means, again, that you're no longer talking about an individual user, right? So just like the carrier use case, there's a pool of IPs and a whole bunch of users behind it. That is also true of Apple Private Relay. One thing that's different for Apple Private Relay from some of the other privacy services, so with VPNs and Tor, is that Apple respects geolocation to a certain degree, right? They will guarantee that the user will be mapped to a pool of IPs that are near their location. And so it's somewhat like a carrier IP in this case. And so if we're seeing a user geolocated to Seattle here, that means they are likely in the wider Seattle region, just like they might be on a mobile carrier, but it means that there are lots of users in this pool. It's not an individual user, and they're using Apple Private Relay. So it means that they're likely also on an Apple device, which is sort of implicit in this. Next, we've got a satellite link. So this is SpaceX, and so we've got a satellite flag. This is another really interesting data point. Similar implications from carrying Apple Private Relay, right? Where there'll be a pool of IPs, a set of users. It is location preserving. Starlink will map users to a pool of IPs near their location. So for sort of geolocation implications are you would treat this similarly to carrier or to Apple Private Relay. But this means that there is someone that is connecting through the Starlink network. They have a satellite dish somewhere. They could be on the move. Starlink now offers it for boats and RVs and all these things. And so there's a bunch of things that are implicitly captured in this. It also means they could be on an aeroplane. Part of our Places data set will detect in-flight Wi-Fi, and Starlink is now rolling out through various airlines. This isn't just Starlink, right? So there's all sorts of other satellite providers that will detect here. There are implications then as well for latency and for bandwidth and all sorts of different things that you may want to account for if you see a satellite link user. And here's an Anycast example. So this is an IP address that, Anycast is an IP address that actually doesn't map to a single physical machine or load balance or even a physical location. And so Anycast IPs are sort of special IPs where the IP address can map to things in many locations. These are usually sort of critical internet infrastructure. They're not generally widely deployed, and so Google's 8.8.8.8 public DNS is Anycast. Cloudflare's 1.1.1.1 is often used for CDNs and sort of really critical performance things. You are unlikely to see an Anycast IP address connect to you. There could be reasons, but you might see, if you're looking at egress and things, you might see connections from devices out to Anycast IPs. And that usually means it's critical internet infrastructure, DNS or name servers or various different things. One really interesting data point, we do a lot of Anycast detection with our probe network, and we actually will map where we see those Anycast hosts on our website. And so we will show you what those are and more context. And so here's an IP address that we map to Seattle because it's an Amazon AWS IP address registered to Seattle. It's Anycast, so it hasn't got necessarily a physical presence in Seattle. But this one actually it does. And we see 86 sites that hosts this IP address on our website will show you a map and various other data points around that. And so there we have it. There we have the overview of 10 different IP addresses, all geolocated to Seattle. So physically, with perhaps the exception of Anycast, right? But they all show up as in Seattle. But there's much richer context and more depth that's available through our data. And so, yeah, going through those 10 examples of what's a kind of real world scenario where you might see an IP address and what's the data that we've got that can help you with that. I think we've got time for one more poll now before we get more into the different data sets.
Great. We are asking our audience here, how do you primarily consume IP data? The answers are pretty self-explanatory. Got 5 different options for our audience to choose from. Unfortunately, this is I think only going to allow one answer per respondent, but what do you like here, Ben? What does your gut tell you about the probable winner?
This was really tough to call. So I think even with our own sort of customer base, we see a mix, and sometimes dependent on use case, sometimes dependent on environment. One thing we're seeing more and more is customers switching between, where an API was maybe a great use case before, they have a new use case, and they switch to download, or the other way around. A pattern we're increasingly seeing is customers needing sort of a hybrid version where they might need a data download for, say, some edge compute where there are a bunch of constraints, and then an API where they can kind of get even richer data and don't have to sort of worry about the infrastructure or keeping the data up to date. So yeah, it's going to be a tough one to call, but I'm really interested to see what the responses are.
Well, let's do some tallying here. Looks like a few folks are still weighing in. A little bit of jostling. I'm going to go ahead and call this one for real-time API lookups. Trending right now at about 33%, trailed just slightly by third-party tools that includes IT, 25%. What do you think about that, Ben? Does that surprise you? Does that confirm your
yeah,
suspicions?
it doesn't particularly surprise me. I mean, APIs are definitely the easiest way to consume our data and usually the best way to get started. And I think unless there's a constraint that rules APIs out, and there can be a whole bunch of those, right? There can be really strict latency requirements or a whole bunch of kind of technical requirements. And for those cases, we offer data downloads, right, where customers can take our data. We also offer customization. And so, if there are specific size constraints, we can work with our customers to kind of meet those. But generally, the API is easiest, right? It requires the least sort of lift from our customers. They can plug in, get started with an API. We can control, adding more data to them on our side rather than them having to go and make changes should they want change in the future. So that's good to see, right? That most people kind of look at APIs. So that's certainly the easiest way to kind of get started.
Well, good stuff. Thank you, audience members, and thank you for the great questions that you're also sending in. We'll get to those at the end of Ben's presentation. Ben, back to you.
Thanks, Terry. Great. So under the hood, I've talked through these 10 examples and the sort of the 10 different real world IP addresses that are all in Seattle, but there's richer context available to differentiate between those, and then you can go act on them and action on that context. I want to shift gears a bit, right, and talk more about some of that context that I've talked about. I want to start a bit with geolocation. And so, while for the bulk of this presentation, the point was, hey, yes, it's Seattle, but you need to know more, right? Geolocation is just the starting point. And that's absolutely true. But also, it's important to be able to trust your geolocation data, right? So if you're building on a foundation of geolocation data, you want sort of strong, solid foundations. And so geolocation being right is really important and foundational. And we care really deeply about accuracy. We care obviously about breadth of data and rich context as well. But it's super important that data is accurate for it to be actionable and to get great outcomes based on that. And so, our approach to geolocation is really around sort of evidence, right, science, measurement, and not guesswork. A lot of geolocation data that has been available on the market historically, there's been a lot of sort of guesswork, a lot of art to it. And lots of reasons why that has made sense historically. A lot of reasons why best effort data is certainly better than no data at all. But our approach is really kind of starting from the assumption that the accuracy is super important. Best effort can be done better, right? How do we kind of push forward what best effort is, and how do we kind of create really, really accurate, really high quality data, and that's important, right? And so one of our sort of really key things is that we base our data. We do use administrative data, right? This is what a lot of geolocation providers will use. What was publicly available IP registration data, geofeeds from providers, location hints that are available in host names, ownership context, and lots of administrative data about IP addresses that in many cases can give you a good approximation around IP addresses are where they are. But we use that as a sort of a hint and informational, rather than assuming that is sort of ground truth data that can be trusted. Two other really critical pieces we layer on top of device telemetry. And so, taking a whole bunch of measurement data, where do we see devices, where are these placed, aggregating that, and using that to get precise location, leverage that into our places data set and other things. And so that gives us, what are observations we see for this network operator for this IP address. So not where is it claimed to be in administrative data, and oftentimes that isn't even a claim. That's maybe where the headquarters are or something else. But where do we actually see activity from this IP address? And the other thing is ProbeNet. And so I sort of hinted at this earlier. We have servers now in over 160 countries constantly actively measuring the internet. So we're pinging, tracing, collecting all sorts of measurement data on the internet. And that gives us sort of physics-based constraints, right? When we're able to ping an IP address, we get the round trip time. There's sort of speed of light constraints on where that IP address can be. With our traceroute data, we can understand how things are connected. And in turn, we put a lot of effort into understanding sort of how the internet is connected, where the flows are, what the constraints are. And as we're actively investing in growing that, buying more and more servers in more and more places, partnering with network operators, IXPs, education networks to get more and more vantage points for us to get a really richer and richer and richer and deeper understanding of the internet that feeds then into geolocation, but feeds into a whole bunch of other data sets as well. And that's sort of been really, really critical for us to kind of give us a whole bunch of accuracy and a whole bunch of really important constraints. And so that's sort of a whole approach is how do we collect evidence, observations, measurements about IP addresses, and put together the best data. So the ProbeNet is this network we've been building. I've talked about the locations and what we collect with it. Historically, that's been mostly used for us internally. So we collect this data. We've partnered with different academic institutions to give them access to the data, a few partners that use it for interesting research and understanding changes in the internet, outages and things like that. One thing we've recently launched is ProbeNet Live. This is completely free on our website. You can go to IPinfo/ProbeNet/live and just kick off a measurement from our probe network. And so this leverages all those locations that we've got as the probe network. You can send a ping, a trace from those locations. You can pick a country and send out a measurement. And so this is a cool way to kind of us unlock more value from these locations that we've got in. Our data team uses this a lot for debugging our own data, for understanding things. This is a cool feature we want to add to the website. And you can use this as well to go validate our own data, right? When you go to an IP page, we'll say, hey, this IP address is in this location. Here's a measurement we've seen, but go fire off a new one, right? That will kind of prove where this is. And so, it's cool. Whether it's a debug tool, just interested or want to play with it, this is available on a website. You can go to it and fire off some internet measurements. And if you've got any feedback and have some fun with it, let us know. And here's an example of that in action, right? And so this is an example IP address that we place in Frankfurt. that we see other providers, other geolocation providers put in New Zealand. And this is and so we're able to kind of reverse engineer exactly why, but also prove that that's wrong. And so it's an IP address with who is registration data. The organization behind this IP address is registered in Germany, but they have a self-published geofeed where they say this IP address is in New Zealand. And a lot of geolocation providers assume good intent from operators and say, well, look, hey, if the operator is telling us this IP address is in New Zealand, we'll trust that and we'll say it must be in New Zealand. And this is an example of one that we can prove isn't, right? And so we've got 5 servers in Frankfurt that are able to ping this IP address in under 1 millisecond. It just, it's not physically possible for this IP address to be in New Zealand. The measurement would take a lot longer. And so in our data set, I believe only in our data set do we show this IP addresses in Frankfurt, and others will put it in New Zealand. And with millions of examples like this where self-published geofeeds will claim a location that we can prove isn't there. On our website, we'll show the proof. Obviously, there's operators or customers can reach out to us and say, hey, everybody else puts this IP address in New Zealand. Why don't you? Do you have it wrong? We say, no, here's the evidence, here's the proof. And then now you can go use ProbeNet Live and recreate that measurement for yourself, and you'll see where it is. This sort of geofeed thing happens for all sorts of reasons. Sometimes just simply mistakes, right? It could be a typoed range, it could be outdated data. This happens for all sorts of sort of non-nefarious reasons. It could be a typo on location, could be that it used to be in New Zealand and moved and then got around to updating it. Could be, they typed the wrong range. Lots of sort of mistake reasons. We do increasingly see this being used adversarially though. And so, you can imagine cybercrime, an operator might want to spin up and pretend that their ranges are not in a sanctioned country where maybe they are. And so they could publish a geofeed and say, yes, all my IPs are in Seattle, when in fact they're not. And that can often be cheaper and easier than actually sending their traffic via Seattle or getting IP space in Seattle. Might be to just have a consumer ISP in, say, Russia or somewhere else and just have a geofeed that says, oh, these are actually in Seattle. And lots of geolocation providers will say, there's this trusted feed, it's in Seattle, and it's a way to bypass that. We see this happen a lot from VPN providers as well. VPN providers love to claim, they have exit nodes in hundreds of countries. And so, back to the use case I said, you install a VPN, in the country drop down, you're able to pick, I want my traffic to exit via, you could pick Christmas Island. Lots of VPN providers claim they've got infrastructure in Christmas Island. Most, if not all of them, don't, right? And so we published some research this year on, I think, only 3 out of the 20 VPN providers that we did a deep dive on actually had infrastructure in every location they claimed, right? It's a lot easier and cheaper for them to say that one of their exit nodes in New York is really in Christmas Island than it is to go out to Christmas Island and set up physical infrastructure and all those things. And so, self-published geofeeds are an important data point that we ingest and analyze. But we see it's our responsibility to kind of validate those, prove those, and lots of them can be really useful hints that we, that do end up in our geolocation data. But a whole bunch of them are provably incorrect, and sometimes for malicious adversarial reasons, sometimes simply mistakes. Often we'll might go back to an operator and say, hey, this looks wrong, and they say, yep, sorry, we made a mistake. And we'll go collect it. And so, the probe network really gives us that capability to both validate geofeeds and any other administrative data, but also then prove where it is, which is really useful. So that's geolocation, right? Why our geolocation is sort of so good and differentiated from other providers, and sort of how important accuracy is. Privacy data is sort of a whole other sort of really important aspect, right? That we sort of covered a whole bunch of the examples today, Tor, VPN exit nodes, residential proxy. So all those flags appear under our privacy detection data sets. 94 million IPs that we flag every 30 days. This is a data set we invest heavily in. We've got a team working on growing this data. 295 VPN services are now attributed by name. That's constantly growing at a rapid pace. 134 residential proxy networks tracked. And the team's doing a lot of work now as well on providing richer provider details. Right now, we'll give you the provider name, NordVPN, Apple Private Relay, working on more and more metadata per provider to give you even richer context there and different actions you might want to take on it. And then places data set. This is the one that was used to differentiate my home IP from Comcast, that were both sort of Comcast as from Starbucks, both Comcast ISP networks, but obviously very different contexts. Our places data set is public preview for our customers today, launching very, very soon in our API plans. Currently 1.7 million IP addresses. So again, those correspond to public Wi-Fi hotspots. About 65 categories. So coffee shop was the Starbucks example today, but we cover hotels, airports, stadiums, restaurants, sort of anywhere. Retail is another big one. Anywhere you might be able to connect to a public Wi-Fi hotspot, we will. Our goal is to cover all of those, give you the name of sort of the place that you're in, the network SSID, a category, and then the precise building coordinates. Also, sort of really interesting ways that you could use this, because it's still in public preview, right? So we're still working with some early customers on this and understanding how they can best get value from it, and they're figuring out exactly how impactful it is. Some of the ones we've already been exploring around sort of employee travel use cases. We've got a bunch of customers that will use our data to protect from, say, employee account takeover, right? We've got a employee trying to remotely log into their work computer. Is it really them, or has there been phishing or something else? One way to sort of bluntly block that with geolocation data is, say we're a US company, we expect our employees to log in from the US. And so a very blunt tool would say, well, let's only allow employees to log in from the US. And that's sort of maybe a great first pass, but then, causes headaches for employees when they travel. And so, if someone's on a business trip abroad, they can no longer get in. And so this is a data set where you can say, actually, maybe that's okay if they're in a foreign hotel or in a foreign airport, and you could update the rules and what's allowed there, or use it as a flag for an investigation. Another one is around sort of behavioral analysis, right? And so if we've got again on sort of the employee use case, does this employee's past behavior match what we're seeing? And so if we've got someone that checks their work emails from a coffee shop every morning, and next week we are seeing a login from a different ISP, so it might previously triggered our rules, right? They're normally logging in from a Comcast, and then next week we see them log in from a CenturyLink IP. But if we can tie that back to a coffee shop, then maybe we want to act on that differently. Maybe they chose a different coffee shop today, but so we could reassess the risk based on that data. And so all sorts of other things, right, that's sort of implicit with this, right? This is not an individual. This could be a public place. All sorts of different ways to kind of leverage this data. But yeah, 1.7 million IPs today, public hotspots. Our plan is to extend this to all public Wi-Fi IPs. It's global data already, so there's great coverage globally. We have really strong coverage of sort of business travel use cases, hotels, airports, libraries, co-working spaces. Pretty good coverage of sort of entertainment things like stadiums, museums, galleries, and now working on kind of capturing the long tail of retail and restaurants, and continuously improving this data set. So if you're interested in this one, there'll be contact details at the end, and always interested to learn new ways that customers can leverage this data. Device count, touched on this a little bit, and so this was implicit in sort of carrier or satellite. We want to make this more explicit, and so leverage a whole bunch of our device data to come up with buckets. And so are we estimating that there is one device on this IP a day, 10, 100, 1,000 plus. This one is in private preview right now. Some of these data points are available on our website. Like I say, any of the IPs we talked about today, you can go to IPinfo/IP and look up. Device data is available there. It's in private preview. We're testing this with a handful of customers and actively investing in it. And yeah, if you'd like to try it out, get in touch with us. And then network allocation. So this is the ASN information. So Comcast, for a long time, we've had classification. Is it ISP, hosting, educational? We're working on offering more and more of the signals that we have behind that on our website. I think on the next slide, we've got a demo. So here's on the ASN page. So not only is every IP address available as a website, as a page on a website, every ASN as well. And we're adding more and more context to that. And so a couple of things we've recently added. were the aggregated geolocation footprint. I believe this is for T-Mobile. You can kind of see where their IP geolocation is concentrated. They could just be interesting, right? You can kind of browse through and see what reach different networks have, where they operate. But it could also be useful for investigations, right? If you see an IP address from somewhere, what network is it on, and where are those locations distributed? How does what I've observed match that? And so it can give you interesting insight. Another is activity. And we leverage this as part of our classification, right? Obviously, residential ISPs have very different sort of behaviors and activity patterns from hosting providers and other things. But we've now made this explicit and available on the website. So you can go to any ASM page and see where activity is concentrated on different networks. They can be really useful for investigations. You're seeing access patterns from this IP address or this ASM that matches the sort of the broader pattern, or is it different? And yeah, lots of cool ways to leverage that. So defensible, not perfect. This slide is about talk about how important data quality is, data accuracy. You see all sorts of vendors make all sorts of different claims. What we try to do is create fact-based data on evidence and observation. We love customers to go test our data, right, and see what impact it has for them. Different customers will observe different segments of the internet, right? And so we do a lot of work internally assessing our accuracy, measuring our coverage, all these types of things. But then different customers will come and see different slices of that. And so we love it when customers come and test our data, evaluate it, see the impact. We love to explore data. We love to get feedback on our data. And accuracy and quality we really, really care about. So it's an overview of 10 IPs, overview of our data. What are the implications for this, right? And so a lot of that is sort of on our customers to go figure out what they want to do with it. They sort of know their environment much better than us. They know what risks they can tolerate. They know how they might want to go remediate things, right? And so one example, like I say, could be employee login, employee account takeover. Then maybe it makes sense to just block the employee because there's an easier remediation. Maybe they call the IT help desk or they call their manager. If you're a grocery store, it's much more risky to say block a residential proxy because you'd be blocking a real customer. So the costs of a false positive there might be higher. The way that we look at it is that we want to provide you as accurate and as rich context as possible so that you're able to go and then come up with a rule or action on it in the environment that makes sense for you. And give you the data points that allow you to differentiate between what might be a false positive or negative or whatever, and then different customers of ours have different tools and ways to go remediate, right? So is this something that you use within an existing piece of software? Is it something that you go leverage in your own environment? And so all sorts of different ways to leverage this data. The principle that we operate from is that more context is powerful, right? And so if you can start with geolocation, great, you might want to block countries or you might want to whitelist locations, but you really want to go deeper than that, right? And sort of what we're focused on is building richer and richer context. We presented a bunch today. We'll continue to add some. So we'll talk about the public preview places data, there's preview device count data, and we've got many more data sets that we envisage us building out over time to give you even richer context. So here's the overview. Here's the 10 IPs. Like I say, you go check them all on IPinfo/IP. We didn't even cover all of the sort of the richness that we've got. We've shown more on the IP page. As I say, you can pivot over to the ASN and see even richer data. This highlights sort of the different data sets we've got that are useful: the geo, the privacy, the place, network, and registration data that allow you to differentiate the different types, and then leverage that in your own workflows. Awesome. That's the end of the presentation. So thank you very much. Like I say, more of this is available on our website. We've got time for some Q&A now, but if we don't get to it, we can follow up. But also, feel free to shoot me an email. My email is ben@IPinfo, and happy to chat more offline as well.
Ben, great stuff. You have offered us a primer on both the basics of IPinfo, but also an advanced course on leveraging that intelligence. So bravo on breadth and depth. We have a bunch of great questions. We're not going to be able to get to all of them, but I did want to at least address a couple of them here. from Ricky in our audience. Hi, Ben. We're already an IP client or IPinfo client. We are concerned about anonymous and residential proxy labels transparency. Do you get it? By which way? Is it ethical to work with third parties? Thanks in advance.
Cool. So I think a few different pieces there, right? So one, yes, obviously we have a whole bunch of really rich data around residential proxies and all sorts of different sort of privacy services, and transparency is something that's really important, and for a few different reasons, right? So one, we think it's important to, our data is based on evidence and observation, right? So I think it's really important that we're able to kind of show our working in some way, right? Lots of data vendors can make claims on their coverage, or but how can our customers go verify that our data is accurate, and then how can we prove that we go verify our data ourselves? Is really important. We do lots of work around that in our various different data sets. I went deep into the sort of the geolocation one in this presentation, right, where we're able to kind of prove, hey, here's the measurement we took. You can go kind of use the probe network. We do that to a degree with our privacy data and our res proxy data. I think it's something that we want to be able to go more and more deeper on across all of our data sets over time. We do include a few fields, right? So we include sort of when we last saw it as a timestamp. We include the percentage days seen. So these are things that our customer able to then go tune sort of what their was positive, or how sort of precise they want to be with that data. And it's a data set we're constantly growing, right? So our goal is to give complete sort of residential proxy coverage. Our data sets try and be sort of fact-based, right? And so, as a fact that we've observed the residential proxy here, we use all sorts of detection techniques, including enumerating IPs, looking for activity. We're trying to, what's the most amount of measurement and observation data we're able to collect, and then kind of craft that into a product that our customers can then go use.
Excellent. Ronald from our audience is asking, does IPinfo data, is IPinfo data able to call historical IP information by date? What are your thoughts there, Ben?
Yeah, so good question. We've had this request before. We don't currently offer. So our customers can download our data and have access to it historically. Internally, we've got a lot of historical data. We do not currently productize historical data, and there's a whole bunch of reasons behind that. We may perhaps in the future. It adds a whole bunch of complexity on the consumer side, right, and makes it more complicated. And so that complexity may be unavoidable, but what we're doing is thinking about a whole bunch of ways that we can capture most of the value of the history in a way that's simple. And so what we hear from a lot of time with customers are less concerned with the specific location at a specific point in time, and more with understanding, has it changed, or how frequently might it have changed, and is it, how long has it been at the current location? And so we are working on a bunch of things like that. One of the things I showcased on the ASN page, I didn't call it out, but in that sort of geolocation overview, we include a bunch of data around how stable the locations on this ASN, what is the sort of the median age. And so we're working on a whole bunch of different aggregations and summaries of the history to bring to the product that we think aren't the perfect solution for the summary, but actually get a long way there, and in a sort of a really simple way. And so we're definitely doing more there. Love to have more customers sort of play with that. If we find out that doesn't actually answer the full sort of problem that customers have, we do have the history available. We do have some customers that we give access to that. But in general, we're trying to look for solutions that get to sort of what is the problem our customers are trying to solve here. And the one that we most commonly hear about is actually want to know if it's moved, right? Like, how long has it been here? And so that's the one that we're actively focused on.
All right. Ben, real briefly, we had a number of questions from John in our audience about IPv6. If you can be ever so brief about this, I know it's a complex topic, but John, one of the questions John asked was, what types of data do you have for IPv6 addresses?
Cool. So great question. All of our data is IP version agnostic. So our data, our geolocation data, privacy data, everything else covers IPv4 and IPv6. We generally have more IPv4 data just because there is more IPv4 data. It's more actively used. We see more signals about it. Our places data has very little V6 coverage just because we see very little V6 enabled public Wi-Fi hotspots. But internally, all the work we do, we care about the internet, right? We don't just care about the V4 internet. And so we care about mapping the whole internet, V4 and V6, understanding that. And we do have a whole bunch of dual stack metadata where we pair V6 and V4 locations. So we do a lot of work on V6 and V4.
All right, that is going to bring us to a close. Audience members, thank you so much for all the great questions. We're compiling them and we will be sharing them with Ben and his team, who can reply to you offline. Apologies that we could not get to those as part of our live session. Our sincerest thanks to Ben Dowling of IPinfo. Black Hat appreciates your time and expertise on getting the most out of IP intelligence. Thank you so much, Ben.
Thanks, Terry.
Thank you as well to our sponsor, IPinfo, as well as everyone in the audience. As usual, you all are just great with your terrific questions, and so appreciate the participation in the polls we threw at you today. Thanks again for your participation and attention. Sometime in the next 24 hours, you'll be receiving a personalized follow-up email with details and a link to today's presentation on demand. You're welcome to share this with colleagues and peers who couldn't have been part of today's live event. The boilerplate now, this webinar is copyright 2026 by Informatech Target. Presentation materials owned by are copyrighted by Black Hat and IPinfo. Individual speakers solely responsible for their content and opinions. Okay, on behalf of our guests, IPinfo and the Black Hat team, I'm Terry Sweeney. Thanks again for joining us for this Black Hat webinar series. We'll see you next time.